Alright, welcome guys. Now this is just function operations. Now as you can see over on the left side I have several different functions, f of x, g of x, h of x, and l of x, and I kind of kept them simple for you guys to actually work with. Okay, but what you're basically going to be doing is adding, subtracting, multiplying, and dividing, and then doing something completely new, which is called a composition of a function. Okay, composition of functions are actually really cool, but we'll get to those in a sec. So basically, if you just follow this operation, that when you see f minus g of x, you're just going to take this function and you're going to minus this function. So you're going to go 3x minus 7 minus parentheses 2x squared plus 4x minus 5. Okay? Alright? So now what you can do, and I highly recommend this, is distribute the negative to each spot and then starts writing out and simplifying. So this becomes negative 2x squared. Okay, then we have the 3x minus 4x, which would be negative 1x. You can write out negative 1x if you want. And then we got negative 7. The negative times the negative becomes 5, so it's negative 7 plus 5, which would be minus 2. And voila, you have it written out in standard form, all set and ready. Okay, now if it says add, just add the functions. It's as simple as that. So if you notice g of x and h of x only has one function in there, so we're just going to go ahead and add it with it. And so it's going to become negative 5x squared plus 4x minus 5. Okay? Alright, so nothing changes except for the x squares. Now if it's times, let me see, L times g. Oof, rough one. Okay, you will be straight up multiplying. So this would be negative 2x minus 1. Okay, and it's going to be over 5. Okay, so I will write that out. Oops. And we will be timesing by parentheses 2x squared plus 4x minus 5. Okay. Now what's probably going to end up happening is I'm going to be distributing throughout the entire portion with the negative 2x and then distributing with the negative 1 and then combining like terms. Okay, that's a lot of busy work, and I always save most of this thing to just show you guys how to work with it. Now when you get all said and done, you should have divided by 5 when you're all set and done. Okay. Alright, now g of x divided by f of x, you guessed it, just do some division. So we have 2x squared plus 4x minus 5 on top, and then g of x divided by f of x is going to be the 3x minus 7 on the bottom. Okay, and as you can see, I can't really factor the top to get something nice, so I can just leave this as this. This has already been worked out. Okay, now when you see composition, it's going to look like you're spelling out a word. I like to look at the most famous one, which is fog. Fog of x. What you're going to be doing is you're going to be taking f of x and you're going to be plugging g of x into wherever f of x or x is in f. So in other words, we are going to be taking all of this and plugging it into this one spot, distributing the 3, and then minusing the 7. So we now have 3 parentheses 2x squared plus 4x minus 5 minus 7. Okay? And so what we get is 6x squared plus 12x minus 15 minus 7. Okay? And obviously just that last part turns into minus 22. Okay? So as you can see, this stuff is really kind of cool that you can actually take something and plug it in itself. And this has actual applications in the next section, so just so you understand that. Okay, now this one right here, L of, what you're going to do is you're going to be taking L and plugging in h of x wherever you see an x inside of there. So we will be taking this and plugging it into this one spot. So this one's going to be really easy. Okay, so we got parentheses, negative 2 times negative 7, x squared. So usually you want to keep parentheses around the part that you just plugged in, just so you know that, like, okay, I'm doing this. Okay, then we got the minus 1. Okay, so that's all the top of the fraction. Then we have to divide by 5 down below. Okay. Alright, so this becomes 14x squared minus 1. I really can't factor that, so I'm just going to leave it be. But it's still going to be over 5, so I'll just leave it as over 5. Okay. The really fun spot about compositions is that this has applications all the way up to calculus. So if you can do compositions, calculus becomes easier, solving inverses becomes easier, just everything becomes easier when you can do compositions. So compositions is just taking one function and plugging it into another and then just simplifying, and it just makes your job a whole lot easier. Okay, that's it for function operations. I'll see you guys later.